All right, we're looking at the 2016, Algebra final exam for NCEA 2. This is question 3e. It says, a symmetrical bridge has a central cable in the shape of a parabola. That's this thing here, as shown in the diagram below. The towers supporting the cable are 15 meters high. So that one there is 15, and this is another 15. At the point midway between the towers, the height of the cable is 3 meters above the road. So at the middle section here, I'm just going to draw a central axis straight down here, because I'm actually just going to call that y, yeah, and I'm going to call this one along the bottom x, yeah. And in doing so, I can now label some things here. Well, this is 40 along. This is going to be 20 on this side, so it's going to be 20. This is going to be negative 20. We know this point here, it's 3 meters up, so the coordinate here is going to be 0. I'll put here 0, 3. There it is, 0 along, 3 up. And this one here, it says a vertical post shown with the dotted diagram is placed 10 meters from the center. So this here is 10 meters. So this really is not drawn to scale, because that there is at the 10 meter mark. All right. And just touches the cable. So it says, use algebra to show the post is 6 meters high. So this bit here, we're wanting to find, we're saying, well, really, what's that coordinate there? Or what's this coordinate here? We want to show that this, in actual fact, comes up here, not at 3, but at 6. So let's see if we can make that happen. First thing I'm going to do is find the equation of this thing, though. And we've got some good pointers here. We've got, well, this one here, for example, we know this is 15 high. So this is 20 along, and this is 15. So this is going to be 20, 15. That's the coordinate right there. So we can use the equation, the general equation for parabola, which is a x minus b all squared plus c. And we've got an a. We don't know a or anything else really, but we do know c. C is going to be, we're starting 3 meters up. We're going 0 meters along. We're still at the 0 point. This is the 0 point there. So it's going to be a is going to be x minus 0 all squared. If I want to write that in, y is equal to a times x minus 0 all squared. Now we do know some values for x and y. X, I'm going to call 20. There it is. I'll make that x and make this one here y. So y is 15. Here it is. 15 is equal to a, which we do not know. X we're saying is 20, and it's all squared. 20 minus 0 is squared. It's still 20 minus 0. Plus 3. All right. So we've got, well, 20 squared is 400. So that's 15 is equal to 400a. Plus 3. I'm going to subtract the 3 from both sides. There it is. So 15 minus 3 is going to be 12, is equal to 400a. Dividing both by 400, and we're going to get, well, 400 divided by 400 is 1. So a is equal to, and if I divide both of these by 4, well, this divided by 4 is going to be 100. And the 12 divided by 4 is going to be 3. So a is equal to 3 over 100. So I can actually just go straight to this now and say, therefore, y is equal to 3 over 100 times x, in fact, just x squared plus 3. So now let's give x a value. So I'm going to make a dividing line here. Here's the equation again. Y is equal to 3 over 100. X squared plus 3. Now, we want to find the value of y when x is 10, because this coordinate here is 10 along and something up. I'm going to call it y. Here we go. Y, there it is. But we know x is 10. There's my x value. X is 10. Y is equal to a question mark. We don't know what that is. So let's throw that in. X is 10, so it's going to be y is equal to 3 over 100 times x squared. Well, that would be 10 squared. I'll just put 10 squared plus 3. Well, 10 squared, of course, and 100 cancel, because 10 squared is 100. And y, therefore, is equal to 3 plus 3, which is 6. And in this case, it's going to be 6 meters. So therefore, the post is 6 meters high. And that would be my answer. Hopefully that makes sense.